Hi, this is Mrs. Kidman, and in this video, we are going to talk about trigonometry, which is the study of angles. So when we talk about the study of angles, really what we're looking at when it comes to trigonometry is right triangles and how their angles are related to one another. So when we learned previously about similar shapes, what we talked about was how those shapes, when they're similar, for example, similar triangles, all of the angle measurements are the same, and their sides are directly proportional to one another. So for example, in this case, if we have 5 over 7, then that's going to be the exact same thing as 10 over what? And we talked about how we can use cross multiplication to solve for it, and we can determine that that missing piece there is going to be 14, right? We use those relationships to determine what those sides are. Now, trigonometry, when we study these angles, what we do is instead of looking at the relationships and the proportions between the sides of two similar triangles, we talk about the relationship and the proportions between the sides of a single triangle and how they relate to one another. So when it comes to trigonometry, we always are looking at the ratios of the sides to what they should be. So depending on what the angle measures are, the sides should always have the same ratio, just like how they do in similar triangles. So if the ratio from 5 to 10 is one thing, notice how 5 to 10, 10 is double 5. So our question mark, the 7 to 14 is also double. So what we want to do is look at this example and talk about how right triangles, when it comes to their two angles and a hypotenuse, have a specific relationship between where their angles are and their different sides. So for example, in this case, we've got our angle down here. Now our hypotenuse, oh, that is not what we wanted. Now our hypotenuse is always going to be opposite the 90-degree angle. That's the definition of a hypotenuse. And then depending on the side that we're looking at, we're going to be referring to our angles in different ways. Now we are going to be referencing everything surrounding this angle here, angle theta. And that's what that Greek symbol there means, is theta, which is often used when we are discussing angles. So we've got angle theta here, and I want to know which angle is opposite that. So the opposite is the one that's on the other side. So it's the side length that's straight across from it. So our opposite side here would be side A from theta. Our adjacent side is the one next to it, which shares a side with that, which becomes one of those parts of that angle. So our angle here is always going to be made up of one leg and our hypotenuse. Now our angle that we're talking about, the leg that makes up it is called the adjacent side. The hypotenuse is obviously the hypotenuse, and the side that is not included is called the opposite side because it doesn't involve that angle. So when we talk about these different ratios that come into play when we're studying angles, what's going to happen is we're going to relate these three different sides. So let's take a look at this one here. It's important that we know which one is our opposite, which one is adjacent, and which one is our hypotenuse. So again, our hypotenuse is the one opposite the 90-degree angle. Our adjacent side is the one next to our angle here. Oh my goodness, it disappeared. This side here is going to be our adjacent side. And then lastly, we have our opposite side, which is going to be the one on the other side of our angle. It doesn't share a side with that angle. That's the opposite side. Now, you may be asking yourselves, why is it important that I know about opposite, adjacent, and the hypotenuse parts of a right triangle? Well, the ratios, depending on what we're talking about, relate the different sides. So let's take a look at this problem. Let's take a look at a triangle here. So if I have this triangle here, not super straight, here's my 90-degree angle. If I'm talking about the relationship between angle theta and the sides surrounding it, we're going to use ABC just like we use in that Pythagorean theorem. These ratios of the sides and the relationship between the angles have special names. So the ratios between the angle and the sides are called sine, cosine, and tangent. Now they're abbreviated this way, but we actually write them. Sine is spelled S-I-N-E. I know it looks like sin, but it's spelled sine. We have our cosine, and then we have our tangent. Now with these three things, we are looking at the relationship between the sides and how they relate to the angle. So the sine ratio, or the sine of theta, is when we talk about the ratio between the side opposite and the hypotenuse. So in this case, when we're talking about the sine of theta, so the sine of theta, what we're referring to is the opposite of theta, which is B over C. Now, an easy way that people try to remember this is an acronym called SOHCAHTOA, which is sometimes an easy way to remember it. Sine is opposite over hypotenuse, cosine is adjacent over a hypotenuse, and the tangent is the opposite over the adjacent. But we're going to talk about what these sides look like when it comes into comparing these. So our sine, again, is the opposite over our hypotenuse, or b over c. Our cosine here is going to be our ca part of SOHCAHTOA, which is our adjacent over our hypotenuse, or in this case, our a over c. And then our last one is our tangent, which is our opposite over our adjacent, or b over a. Now, these ratios are special names for the ratios of the sides and how they relate to that angle. And we can use these consistently throughout. So any similar triangle, so any triangle with 30, 60, 90, their sides are going to have these same ratios as we divide them as a triangle, as any other triangle with 30, 60, 90. So that's the cool thing about the relationship between similar triangles and trig, is that we can see that these ratios of their sides are directly related to their angle. And we know that this will work for any triangle with these angles because any triangle with the same angles are similar triangles. So let's take a look at some examples here when we're talking about these different ratios of our sides. So we kind of did this previously, but we're looking at sine, cosine, and tangent of theta here. Now remember, we're going to use that acronym SOHCAHTOA to help us kind of remember what it means. Now, SOHCAHTOA is not anything specific other than helping us designate which sides am I looking at. So sine, again, is opposite over the hypotenuse. So our opposite from angle theta here is going to be the one not included, which is A, divided by the hypotenuse, which is C. Then we want to talk about the cosine. Now the cosine is the ratio of the adjacent side over the hypotenuse. So the adjacent side, if I could spell adjacent, ADJ, over our hypotenuse. And our adjacent side is the shared side with our angle that's not the hypotenuse. So that's going to be B over C. And then our last one is our tangent, which is the opposite over the adjacent side. And opposite over adjacent in this case would be A over B. And then what we can do is we can look at those ratios, and that helps us determine these different things. So if I typed into my calculator, there's a button on there, sine of a certain degree, it would be equal to whatever that is. So it depends on where that angle is, which refers to which sides are sine, cosine, and tangent. So again, it's always going to be that opposite over the hypotenuse when it comes to sine, or that SO part of it. Our cosine is always going to be the adjacent over the hypotenuse, which is the ca part of it. And then our tangent is always the opposite over the adjacent, which is how we get the TOA part of SOHCAHTOA. So let's list our sine, cosine, and tangent of this theta angle here. So sine is opposite over hypotenuse. So in this case, it's going to be B over C. Our cosine is adjacent over hypotenuse, or A over C, and our tangent is opposite over adjacent, or B over A. So notice how between these two triangles, we switched the location of theta. None of the labels changed otherwise, but all of our ratios changed. Because the angle is different, the sides are different. So let's practice finding a sine, cosine, and tangent of these different triangles here. So in this triangle, we want to identify the ratio of each of these, sine, cosine, and tangent. So with this being angle theta, sine, remember, is opposite over hypotenuse. So what we're going to do is take the opposite, which is 12, over our hypotenuse, which is 13. So the sine of theta is going to be 12 over 13. The cosine of theta is going to be the adjacent over the hypotenuse, which is going to be 5 over 13. And then lastly, our tangent is the opposite over the adjacent, which makes it 12 over 5. So those are those three trig ratios. Now there are additional ratios that we explore when it comes to trigonometry, but they're all based originally off of these three. So we want to continue with these three. Now let's take a look at this one. So in this case, we want to identify the three trig ratios of this triangle. Now, before we can do that, we actually want to know what all of the sides are. So how could I find the missing side of a triangle? Well, in our previous video, we talked about the Pythagorean theorem and how that's used to find missing side lengths of triangles when they're right triangles. So let's do that. We've got 2 squared plus b squared equals 7 squared, or 4 plus b squared equals 49. And then we can subtract 49, so we get b squared, or 4 from 49. B squared equals 44. So b equals the square root of 44, which is the same thing as 2 square root 11, maybe, if we can write a square root. 2 square root 11. So that 2 square root 11 here is what this side is. And so then we can use that to write our sine, cosine, and tangent ratios here. So sine is opposite over hypotenuse. So this is going to be 2 root 11 over 7. The cosine is going to be 2 over 7. And then our tangent is opposite over adjacent. So 2 root 11 over 2. And this one will actually simplify just into the square root of 11. So those are those three trig ratios that we're looking at there. Now, if we want to find sine of A in a certain triangle, what we're going to do is that's, again, just listing out that ratio. So if we have a triangle that looks like this, and we want to find the sine of angle A. So if this is A, what happens when we do A, B, and C is angle A is going to be opposite of side length A, and B is going to be opposite of side length B, and C is going to be opposite of side length C. So we use capital letters to denote the angle across from the side length. And that's because when it comes to triangles, there's a direct relationship between the angle measure and the side length. So the smallest angle has the smallest side length across from it. The biggest angle has the biggest side length across from it. And they're proportional that way, in the sense that the bigger the angle, the longer the side. And we know that. So in this case, as we're defining our triangle here, we know that angle A is going to be the one opposite A, and angle B is going to be the one adjacent to A. So if we want to find the sine of A, that means we need the opposite over the hypotenuse. Now, how could we find the opposite over the hypotenuse? Well, first we have to find the hypotenuse, because in this case, we found out that A is 5 and B is 12. So to find the sine of that, we need to then find what C is. So 5 squared plus 12 squared equals C squared. Well, 5 squared is 25 plus 144 equals C squared. And that's 169 equals C squared. And guess what? If we square root both sides, we end up getting 13 for C. So C is 13. So if we're talking about the sine of angle A, we're going to do the opposite over the hypotenuse. And so that's going to be equal to 5 over 13. Awesome. Let's take a look at one more example where we're talking about these triangles that we're trying to find the ratios of. Now, in this case here, I want to talk about this one. Now, this problem is asking us to find the tangent, but what they gave us was the cosine. So how does this relate? Well, let's look at drawing a triangle here for ourselves. So let's pick an angle. I'm going to call it this one. And this one is going to be angle A. And then we've got B and C. And what we want to do is find the tangent to this angle B here. But what we know is that the cosine of A, or the adjacent over the hypotenuse, this is 7, and this is the square root of 13. So using that, we need to find B, because in order to find the tangent of it, we need to find this length BC here. So how can we find this length BC? Well, we have to use that Pythagorean theorem. So the square root of 13 squared plus x squared equals 7 squared, or I guess plus BC squared is what we can call that. So this is 13 plus BC squared equals 49. If we subtract 13 from both sides, 49 minus 13 is going to be 36. So BC squared equals 36. If we square root both sides, we end up getting that BC is equal to 6. So this side is 6. So then to find the tangent of B, which is this angle, I need to do the opposite over the adjacent. And so what that ends up being is our opposite side, or the tangent of A, is equal to our opposite, which is the square root of 13, divided by our adjacent, which is 6. And we are not finding it of A, we are finding it of B. I apologize. The tangent of B is going to be the opposite of angle B divided by the adjacent. And that, in a nutshell, is how we can do those trig ratios. So I'm going to follow one more example here, and then you will be good to go on your own of what a triangle might look like if we're looking for these things. Now, sometimes, again, we're going to be given the sides of the triangle, and we want to write the sine, cosine, and tangent ratios. Sometimes we're going to be given 2 of the sides of the triangle. We have to find the third one, and then find our trig ratio. And sometimes we're going to have to find a trig ratio based on another trig ratio, which is where we have to know what those ratios mean. So let's take a look at this one last example here. So I'm going to draw our triangle. And this is going to be triangle ABC. And I know the tangent of A, so if this is angle A here, the tangent, or the opposite over the adjacent, is going to be 12 over 13. But we want to find the cosine of B, which is this angle. So to find the cosine of B, what I need to know is the adjacent side over the hypotenuse. Now I know the adjacent side to B is 12, so I need to figure out what this hypotenuse is. So again, that Pythagorean theorem comes into huge play here as we're trying to figure out what that length is of AB. So we can do 12 squared, which is 144, plus 13 squared, which is 169, is equal to AB squared. And as we do that, 144 plus 169 equals 313. So as we go to square root that 313, what we end up getting for AB is the square root of 313, which is approximately 17.69. Now, because of the way that we like to do math, we don't want to write it as that ratio there. So what we're going to do is we're actually going to divide it by we're going to break it down into some of its common factors to see what happens here. So what are some numbers that divide into 313? Well, as we look up a list of factors of 313, we find out that it's actually a prime number. So guess what? That's as simple as it gets. So when we're looking at the opposite over the adjacent, this is actually the square root of 313, which is about 17. So then as we do our math here, the cosine of B is actually going to be 12 over the square root of 313, which we can then multiply by 313 to get rid of it if we would like to, or the square root of 313 in the form of 1, and get 12 times the square root of 313 over 313 is that ratio that we're looking at there. Wow. So if you have any questions, that is trig ratios, just a basic introduction to trig ratios. But again, when we're talking about trig ratios, we're talking about the relationship between the opposite sides and the angles. So the sine, or the opposite side divided by the hypotenuse of an angle, has a same ratio as any other triangle with that same angle. The cosine is the adjacent over the hypotenuse. The tangent is the opposite over the adjacent. And a very easy acronym that people use to remember it is SOHCAHTOA. SOH, sine is opposite over hypotenuse. CAH, C-A-H, cosine is adjacent over hypotenuse. And TOA, where tangent is opposite over adjacent. If you have any questions, feel free to reach out, but that is an introduction to trig ratios.